breaking vectors into components with trig. Breaking vectors into components is essentially the reverse of adding vector components to find a resultant. As with adding components, we have two methods, by hand and using trig. This video goes over the trig method. If you want to draw the vectors by hand, watch the video Breaking Vectors into Components by Hand. Find the horizontal and vertical components of the vector below. We can do this by first sketching the vector and its components. This will result in a right triangle that we can then use sine and cosine to find the horizontal and vertical components. To find the components, first sketch the vector, 20 newtons at 30 degrees, and its vertical and horizontal components. Keeping in mind, the two components always add to get the resultant in tip-to-tail fashion. We should have a vector to the right and up. I'm going to go ahead and sketch this on the picture. I've got a vector to the right and a vector up. You can always check to make sure that you've done it correctly. My original vector went to the right and up, so I know that some part should be to the right and some part should be up. Now that I have my components drawn, you can see we have a right triangle. The resultant vector I was given is the hypotenuse, and you know that the angle is 30 degrees. Let's start with the horizontal component, shown here in blue. The horizontal component is adjacent to the angle, so remembering SOHCAHTOA, for the adjacent side, I'm going to want to use cosine. Cosine of 30 equals the adjacent side, which I'm trying to find, let's call that x, divided by the hypotenuse, which in this case was 20. That means x equals 20 times cosine of 30. And that may be something you need to plug into your calculator. You'll find that x equals 17.3 newtons. So that is our horizontal component, 17.3 newtons. The vertical component is the opposite side, so I'm going to use sine. Sine 30 equals the vertical component, let's call that y, divided by the hypotenuse of 20. So y equals 20 times sine of 30. Sine of 30 happens to be 1/2, so y equals 10. That means the vertical component is 10 newtons. I'll do the same thing for example 2, starting by sketching the components. This vector goes up and to the left, so I know I'm going to have a horizontal component to the left and a vertical component that is up. I've got a right triangle with my angle 65 included in there, and can use trig functions to find the horizontal and vertical components. Again, thinking SOHCAHTOA. Starting with the horizontal component, I'm going to use cosine because this is the adjacent side. So cosine of 65 equals x, that's what I'm trying to find, divided by the hypotenuse of 12. Plugging that into a calculator gives you 5.07 newtons. Now, since this force is to the left, I know that the component has to be negative. Negative 5.07 newtons. For the vertical component, this is now the opposite side, so I'm going to use sine. Sine of 65 equals the adjacent, which we'll call that y, that's what I'm trying to find, divided by the hypotenuse of 12. So y equals 12 times the sine of 65. You may need to plug that into your calculator. That equals 10.9 newtons. Okay, for the last example, what's important is that this angle is actually measured from the y-axis, not from the x-axis. Again though, we'll sketch our vector components. So here I have some vertical component up and a horizontal component to the right. You'll notice in all of these examples, I draw the components so that the angle is included inside my triangle. I'll start again with the horizontal component. Since this angle is measured from the y-axis, not the x, this is actually now the opposite side. So I'm going to actually want to use sine. Sine 75 equals that component divided by the hypotenuse, which here was 15. Plugging that into a calculator gives me 14.5 newtons. So the horizontal component is 14.5 newtons. For the vertical component, now this is the adjacent side to the angle, so I'm going to use cosine. Cosine of 75 equals the vertical component divided by the hypotenuse of 15. Plugging that into a calculator gives 3.88 newtons. That's up, so that's going to be positive 3.88 newtons. In breaking vectors into components, it's always easy to confuse the sine and the cosine components. If the vector is sketched for you, you may want to look at the picture to see which component should be bigger. Looking at this picture, it's clear that the horizontal component is larger than the vertical component. If I got a larger vertical component, that could tell me maybe I switched sine and cosine. If the vector is not drawn for you, it might not be a bad idea to sketch it, intentionally drawing it either larger or smaller than 45 degrees so that it's easy to see which component should be bigger. That way, if you confuse sine and cosine, you'll be able to catch it.